So we continue from where we left off from our video. The previous video we did our geometry, meshing, we did our physics, and now all we're doing is we'll be doing this. So we continue from where we left off from our video. The previous video we did our geometry, meshing, we did our physics, and now all we're doing is we'll be doing the study and plot some of the results. We're using a time dependent study, and the problem is not ready for solving. Okay, so you click on the time dependent study, and under the time dependent study you look for the study settings. In here we have the times range. You have to change it to 0, 5, and 120. We change the range over there to range to bracket 0, 5, 120. Afterwards, what we'll do is you look for the solution and you show default solver. You want to use a manual scale of 1 for the electrolyte potential dependent variables to help improve the accuracy of the solution. So you have to show the default solver, go to solver configurations, solution 1, dependent variables 1 node, and you have to click the electrolyte potential. You will see me illustrating that shortly. After we're done that, we can compute our work. Usually computation of this work sometimes it takes some time depending on your system's speed, the RAM, and all that. Okay, we encountered an error and talks about the boundaries, geometry 1, and the variable. So we have to trace where this problem is coming from and we have to correct it. I think there was a place that we did not write there. We didn't input it correctly, so I'm going to trace that place and we'll solve that shortly. I'm going to trace that problem and I'll show you how it can be solved so that we continue. So we go to the electrolyte reaction 1. There you notice that there's this part, equilibrium potential. I did not input it correctly, so I'm going to input it well so that this mistake will be rectified so that we can compute our work. It should change from this yellow sign to a black sign. So when it's yellow like this, it indicates that it's not known, so you have to correct it properly, and you realize that it's the same thing that we have in the parameters. You can equally copy it from the parameters and go and paste it over there. Now that you're done, what we'll do is we can continue to now study, complete the work to get our results. It's gonna take some time, but I'll just plead with you to please be patient. You wait a little while, so we get the results. This will finish computing, so we get the results. Okay, now we don't have any error. We don't have any problem. So when you follow the procedures, okay, the convergence plot is now coming, so meaning that we are the it's actually good and we'll be having some results very soon. There's no problem for now. So if you follow what I showed you from the beginning, I had a previous video that I started the first part of this, and this is the continuation of this part. And if you follow the previous video that I uploaded earlier on car door, you realize that I first imported some parameters from file. Okay, you can see the convergence plots now. Okay, so like I was saying, I imported some files, and if you need the files, please you can send me an email. I'll make sure I send it to you. If you need any files for this work, please send me an email, and I'll do it. I'll send it to you. And if you have any questions, too, please let me know. You can just send me an email, or you can just write it down in the description in the video, in the comments, and I'll go out to reply. Most of the times, um I respond quickly when you send me an email. So whilst you're waiting for this model to finish studying this study, um, I also like to also recommend all viewers to join our membership group. We have different categories, and it's actually there to help students or people who need assistance with their work. Maybe you need some one-on-one assistance, personal training, have difficulty in your project or any other thing. Please feel free, send me an email, and I'll be more than much happy to assist you. Okay. Yeah, so it's actually converging, and that's good. It should take a little while. Still waiting. Will be after it's done. It will give us some plots on the electrode potential versus adjacent reference. The electrode potential versus adjacent reference. Also, we'll look at electrode potential for the cathode upside. We'll look for as well for the anode total film thickness as well and all that. So we'll be getting so making a lot of plots from this video. So let's see. Let's wait a little bit while it comes. Be waiting. You should wait a little bit. Um, please. Okay. Okay, we're still waiting for this video. This part to be done computing. If you have any questions, please let me know in the comments section and I'll do what to respond. Alright, so it will take some little time. Take some little time, but please let's wait a little while. Let's wait. So, like I was saying earlier, if you have any challenge with your project, maybe you're trying to learn COMSOL, you have some questions, you're building a model for your work, and you have some challenges. I recommend you just send me an email. Just tell me about your work, and I will be more than happy to assist you. That's why we have this channel to help a lot of people, including you, who are in the part of learning or in the part of solving a project or working on a project. It's gonna take a little while. Whilst you're still waiting, I just want to talk a little bit about this model. It's about electrocoating, and you know that method of electrocoating is used in various industries, and for instance, in the automotive industries. What is it actually used? It's used to apply maybe the priming paint layer on car bodies. So it is possible to achieve maybe a uniform paint layers even for complex body shapes. And in this example of electrocoating of a car door where an electrolyte is in dispersion of colloidal paint particles, and the paint particles are deposited on the cathode surface. So we started by building our geometry, which was which has a single electrolyte domain, with the electrodes being represented as boundaries. We have the quarter and semi-cylinder surfaces representing the anodes. The car door cathode is completely immersed in the electrolyte, so the car door is completely immersed in the electrolyte. So the car door geometry is a surface geometry, and the electrolyte surface is modeled using the thin electrode surface node. Okay, so I think it will be done soon. We're almost done. Then we're almost done. Almost done. Almost done. I think some few minutes will be done, and we'll get the results. Okay, so now we're done. We're done now. Let's look at the electrode potential versus adjacent reference. So you will find it under the results, and I would like you to click electrode potential versus adjacent reference. I want you to go to the electrode potential versus adjacent reference. Look for where we have the settings for the 3D plus group, and what we'll do is we'll just type electrode potential. So in the settings window, under the 3D plus group, we just type electrode potential. Okay, so when you click on it, it will load the plots. It's loading the plots. It's loading the plots. So we wait a little while. Just wait a little bit. Then you go ahead to at the label. You just have to type electrode potential versus adjacent reference, all electrodes in the label text field. After you're going to duplicate it. After changing the label, you're going to duplicate it. You're going to duplicate it. You right click and you select duplicate. And in the settings window for the 3D group, you type electrode potential versus adjacent reference, cathode upside in the label field. So after duplicating, you're going to type electrode potential versus adjacent reference, cathode upside in the label text field. Electrode potential versus adjacent reference, cathode upside in the label text field. You then look for the surface slit 1. Surface slit 1. It's under the adjacent reference, adjacent electric potential versus adjacent reference cathode upside node. You click surface slit 1, and in the settings window for surface slit 1, you locate the expression on the downside section. In the expression for the downside section, you locate the expression on the downside section. So for the expression on the downside section, there will be an expression text field. So surface slit 1, like I was saying, you locate the expression on the downside. Expression on the downside, and the expression field, you you just change the last letter to U. So it's supposed to be root dot comp1 dot cd dot evsrefu. And you click to expand the inherit style from the plot and you choose none. And you go to inherit style you choose none. So the plot, you choose none. After you click the surface one, in the settings window for the surface one, click to expand the inherit style section. Right click surface one and choose disable. You have to disable it. Right click on it and you choose disable. Right click on it and you choose disable. Afterwards, we'll go to the model builder, click the electrode potential versus adjacent reference cathode upside, and in the electrode potential versus reference cathode upside toolbar, you click plots, and afterwards you duplicate it. And afterwards you duplicate it. You duplicate this, you right click and you choose duplicate. So what we're going to do is we're going to create another 3D plot group for the cathode downside. So that's why we are duplicating it. So you see we'll change the label to electrode potential versus reference adjacent reference cathode downside. We change it to cathode downside in the label text field, and we change it to downside. So from upside, we've changed it to downside. We've changed it to downside. Can you note? So in the model builder window, expand the results where we have the electrode potential versus adjacent reference cathode downside node. Click on surface slit 1. Click on the surface slit 1. Surface slit 1. Good. So in the settings window for surface slit 1, locate the expression on the upside section. In the expression text field, you change that expression text field and you just change the last letter to D. So it will change from U to D. So it will be type root dot comp one dot cd evsrefd efd. Then you locate the expression on the downside section. In the expression text field, type root dot comp one dot cd efsrefd. So the last letter will change to D. Will change to D. After that, you click on plot. Just click plot, it will plot. And the next thing we'll be doing is the total electrode thickness. So under the results, click total electrode thickness change. In the settings window for the 3D plot group, you change the name, the label, you change it to total film thickness cathode in the label text field. Total film thickness cathode in the label text field. So the total film thickness at both sides of the car door was plotted by default. Now we're creating a separate upside and downside plots. We're going to duplicate this. You right click it and choose duplicate. And in the settings window for the 3D plot group, type total film thickness cathode upside, label text board upside, and you just look for the surface slit. So after you tap upside, you go to the total film thickness cathode upside node, then you select the surface. So after putting in upside, you look for the total film thickness surface slit one. Look for the surface slit one. You're going to do some changes in the expression over there. So the surface slit one, and locate the expression on the downside section. In the expression text field, type root.comp1.cd.sbtotu. So in the expression text field, type root.comp1.cd.sbtotu. After you click plot, after plotting, you go ahead to the model builder window, right click total film thickness cathode and choose duplicates and choose duplicate. In the settings window for the 3D plot group, type the total film thickness cathode downside in the label text field. You change the name to cathode downside in the label text field. You change it to downside. And what you do next is in the model builder window, expand the results total film thickness cathode downside node, then click surface slit 1, surface slit 1, surface slit 1, surface slit 1, and in the settings window for the surface slit, locate the expression on the upside section and you change the last letter to D, then you click plot, you click plot. Finally, we compare the total upside and downside thickness at a specific point on the car. So we add a plot group and choose 1D. We are comparing the upside and downside now. So we want a specific point on the car door geometry. So we want to compare. So we add a point, uh, we add a 1D plot group. So you select 1D plot group from and locate the plot settings. You locate the 1D plot group. First, you type total film thickness comparison. So we label it as total film thickness in the label field. Total film thickness, the label field. Total film thickness comparison in the label field. Locate the plot setting, select y-axis checkbox, and in the associated text will type total film thickness. Okay, the y-axis. We're going to select the y-axis, and we're going to select total film thickness. We're going to type total film thickness. Type, click the y-axis, and Select total film thickness. And in the total film thickness comparison toolbar, so we type in a total film thickness in here. Total film thickness. Put total film thickness. Total film thickness. After we just select the point, we'll be selecting the point, the particular point on the car door we'll be using for the comparison. We'll be selecting the particular point on the car door that we'll be using for our comparison. How do we do that? How do we do that? How do we do that? So under the total film thickness comparison, click point graph. Click a point graph. Click on the point graph to add, select the point. So you click, you have to right click to add a point graph. Right click to add a point graph. You have to add, right click to add a point graph. The point graph, you select 139 only. 139 only. In the settings window for the point graph, you click replace expression in the upper right corner of the y-axis. From the menu, you choose model component 1 and primary current distribution, and direct dissolving depositing species. Select the total film thickness change up. After you expand the legends, locate the y-axis data unit list. You choose micrometers, show legends. So you have to select the total film thickness change. It's under the dissolving depositing species.